Hello, my lovely students. How are you? Today we will continue our lesson about the separation techniques. At the end of this video, you should describe distillation, simple and fractional, and to describe crystallization technique. Food tastes good due to the presence of salt. All of us add salt to our food to taste good. Do you know from where salt is obtained? Yes, you know that. From seawater. The seawater is containing the salt. So, the salt is obtained from the seawater. How? By a process called crystallization. Let's see what is the crystallization. So first, crystallization is used in the production of table salt and other crystal salt substances like the copper sulfate crystals, and also to obtain sugar rock candies. Delicious. Yes. How is obtained? So crystallization is a physical separation technique. Separate a mixture. But which type of mixture? Let's take the example of the table salt, which is solid with water, like the seawater. So the table salt dissolve in water, so it's a homogeneous mixture. So crystallization, separate a solid liquid homogeneous mixture. How? Crystallization is depending on the vaporization of water, and the solid will remain. It can be slow crystallization, so the evaporation of liquid will take place slowly under the action of sun, and the crystals will remain at the end, okay, as a solid substances. They are called crystals. Or it can be fast crystallization under the action of heat. We heat the mixture, so the liquid will evaporate and the solid will remain, which is called the crystals. Type here, I want to ask you a question. If I have the same mixture used before, which is water and table salt, and I need the pure water, not the table salt, I need to take a pure water, can I use crystallization? The answer is no. Why no? Because the water will vaporize during this separation. So I should prevent water from escaping. Very good answer. So we use distillation. Let's see what is the distillation. I have two types of distillation, simple and fractional. First, simple distillation, we need the materials: Bunsen burner, thermometer, round bottom flask, condenser, and Erlenmeyer flask, and we put them in this setup. This is the distillation setup. So how its simple distillation take place? I have here the Bunsen burner is under the round bottom flask, and the round bottom flask is connected to the condenser, then to the Erlenmeyer flask, and in the condenser I have a tap water is connected to it to cool the vapor. How? Let's see. First, I put the mixture, which is the solid liquid homogeneous mixture, in the round bottom flask, and we start heating. When we heat, the temperature will increase, and when the temperature reach the boiling point of the liquid, so here the liquid will vaporize, yani change from liquid into gas. So the vaporization will take place in the round bottom flask. The vapor, the water vapor here will go upside, and it can't be go outside, it will go to the condenser. The condenser here, your teacher, is connected to the tap water, which the water from the tap is turned around the condenser to cool the vapor. So here the cooling will take place, yani decrease in temperature, yani condensation. So change from gas into liquid again. Yani the gas here will change into liquid. The liquid will go down to the Erlenmeyer flask. So here I get a pure water, which is called distilled water. In general, this liquid is called distillate. Okay, this is the distillation, simple distillation. Let's observe this video to understand it well.
Let's understand this with an experiment. Take some salt water in a retort and heat the retort till the steam comes out of it. We will see the steam getting collected inside the beaker in the form of droplets of water. advances and reaches the beaker, and the salt left behind in the retort.
The main useful of simple distillation is to produce distilled water. Distilled water is used in the synthesis of medicine, cosmetics, and other substances. Now, here another question. If I have a mixture of two liquids together, miscible liquids, and dissolve in each other, so in homogeneous mixture, for example, water and alcohol, can I use simple distillation? The answer is no, because the two liquids will vaporize. But your teacher, think well, the two liquids do not have the same boiling point. They will not vaporize at the same time. So I will use the fractional distillation. Fractional distillation is similar to simple distillation, but we have fractionating column, okay, before the condenser. The fractionating column keeps the vapor far from each other. Let's see how. We want to put the mixture in the round bottom flask and heat, okay. The temperature will increase, but the liquid that has the lower boiling point will vaporize first, and the vaporization will take place to change from liquid into gas. The gas will go to the fractionating column that keeps the two vapors far from each other. Then it will go to the condenser. In the condenser, the condensation take place, change from gas into liquid. The liquid will collected in the Erlenmeyer flask. So, during this time, the temperature will remain at the boiling point of the first liquid. When the first liquid change, the temperature will continue increasing, and will it reach the boiling point of the second liquid, then the second liquid will vaporize and collected in the same way. Let's see that useful of fractional distillation. The main one is to separate the fuel which the crude oil is containing a mixture of liquids together, benzene, diesel, kerosene, gas, butane, methane, which is a homogeneous mixture of liquids, so we use fractional distillation to separate it. For application, here I have three mixtures. The first mixture, water and potassium permanganate. Potassium permanganate is a solid substance, has a violet color which dissolve in water. The second mixture, water plus big beads, and the third mixture I have water, alcohol, and rice. First, I want to indicate the type of each mixture. Mixture 1 is solid liquid homogeneous mixture because the potassium permanganate dissolve in water. Mixture 2, solid liquid heterogeneous mixture, and the third one is a heterogeneous mixture because the rice didn't dissolve in alcohol and water. Suggests a method to separate each mixture and list the materials used. The first mixture, because it is a solid liquid homogeneous mixture, so I will use a simple distillation. Very good, as we know. So the simple distillation, we need the materials Bunsen burner or any source of heat, and round bottom flask, condenser, Erlenmeyer flask, and thermometer. In the second mixture, we can separate it simply by our hand because it's safe to take the beads by using our hand. The mixture 3, because we have water and alcohol or rice, I can remove rice by filtration, and then I use fractional distillation to remove water and alcohol. So first we use filtration, then we use fractional distillation. The materials used in filtration are the stand with the clamp, and I use beakers, I use funnel and filter paper. And the fractional distillation, we use Bunsen burner or any source of heat, and round bottom flask, fractionating column, condenser, and Erlenmeyer flask. Okay, so please, my students, you should please rewatch this video many times in order to understand it well and resolve the application again.